Hello, it's time to begin, and we're going to be continuing our discussion of the flood. Last time we focused on the changes of the earth itself. Now we're going to be focusing on the changes that the water itself caused. Just like last time, the majority of our text is going to be from Genesis 6 through 8. A little review, we need to make sure that this was not a local flood. We went over this last time. For a variety of reasons, because the water was 15 cubits over the mountains, because the Bible says that all flesh everywhere a number of times, and the promise itself also says that this is not a local flood, a global flood. Because if it was just a local flood and God said that he would never flood the earth again, then we've had many local floods since. And then the basic timeline the Bible gives us, Noah was in the ark 370-ish days. The whole earth was covered for a likely maximum of about 110 days. The ark itself wasn't lifted up until about day 40. This is after all the rains. And then the ark landed on Mount Ararat about day 150. And that gives us our 110 days. And then they stayed in the ark for an additional 100 some days for a total of 278 days when the dove returned with the olive leaf. We talked about the rapid upwelling and how the new ocean floor, being less dense because it's hotter, pushed up the ocean anywhere from 0.6 to 1.2 miles. This would have covered the entire land in water. The pre-flood world was not as high as our world is because the sheer heights of the mountains are all from vertical tectonics that were caused by the horizontal tectonics, which was caused by the flood. And so we need to make sure we're aware of that all the water that caused the flood is still here. As the ocean crust cooled, it became more dense and then sunk down. We also talked about earthquakes. There were a ton of earthquakes at this time because you had the old ocean crust going underneath the continental crust. Just like today, when the crust goes under, it catches and then releases, and these are causing earthquakes. Unlike today, these would have been much, much larger because the movement would have been much faster. And all this friction, all this movement would have created a lot more heat, and that would have led to a lot of volcanism. This volcanism started out very big during the flood, and since then has diminished with each subsequent eruption, as you can see here. But still, they produced a lot of debris. So these are just some reminders from our lesson from last time. Now the waters themselves. The waters didn't just rise up. They came with force. There were a number of tsunamis at this point in time because tsunamis are generated by rapid plate movement. And that gives them the force they need to sustain themselves for vast distances. Now, a tsunami is formed by that movement of the ocean plate under the continental plate, gripping and releasing. That release basically can uplift the ocean floor a number of feet, dozens of feet today. And that push, basically just like us pushing water, it makes a humongous wave. And they can be very, very powerful. In 2011, there was a 9.1 earthquake. That is extremely powerful. The fourth most powerful recorded since 1900. That's on the Richter scale. This occurred about 20 miles below and 45 miles east of the coast of Japan. So not right there, but still relatively close. It was a 160-foot slip, meaning that the continental plate slipped 160 foot. And it caused the seafloor to rise about 23 feet. The tsunami out at sea isn't as noticeable until it hits land, just like all waves. In the ocean, they're much smaller looking because the majority of it is under the surface of the water. But when it goes onto land, it reached 133 feet above sea level and traveled as far inland as 6 miles. You can see some pictures. It was very devastating and even overtopped a seawall designed for tsunamis. And these are the kind of tsunamis that would have been minuscule compared to the ones of the flood. Based upon the John Baumgartner model that we discussed last time, you can see there the continents and their movement. You can also see in this field of view on the right side the tsunamis. Based upon the calculations of movement and some water formulas, the red would have been the high points and the blue would have been the low points. It would have averaged every 6 minutes somewhere on the world, there would have been a tsunami forming. And this is just averages. So that would have been 240 tsunamis a day, 36,000 tsunamis over the course of the 150 days that the floodwaters were going to its peak. Now, these would have been massive slips, just humongous slips in movement, creating humongous earthquakes and humongous waves. The waves could have been anywhere from 6,000 to 8,000 meters tall. Again, wouldn't have been that noticeable on sea, but when they got to land, they would have traveled far inland and caused a lot of destruction. And they would have been impossible to avoid. They would have been traveling at 20 meters per second, or sorry, 200 meters per second. I dropped off a zero there. And so once you saw the tsunami, it was basically the end. And there have been a lot of these. The oceans would have been the safest place, but even that would have been very safe. Tsunamis cause a lot of damage by a process called cavitation. This basically has to deal with a lot of the forces going on in water. They can create air bubbles, and those bubbles basically just collapse and can have such great force that they even destroy ship propellers. If a ship propeller spins too fast, it can actually destroy itself. I mean, metal designed to withstand these pressures are destroyed by this process. And it would have been such a great amount of destruction caused by these tsunamis that this is likely the main way in which the old world was destroyed. There would have been earthquakes destroying things, the continental movement would destroy things, but this would have caused enough destruction and erosion to supply all the sediments laid down by the flood. A very destructive process. So when things were taken by the water, they did not drown, they were obliterated. And it can produce quite a bit even today. Cavitation occurs when the water is moving about tens of meters per second. And remember, the flood tsunamis would have been going over 10 times that. It can reduce crystalline continental crust into sand-sized or small particles. It really is kind of amazing that they have anything that's larger than a grain of sand from this time period. And there have been quite enough force to sustain all this. You can see in the top right a earthquake today and the subsequent readings of its force around the Pacific. And remember, the earthquakes today are quite small in comparison. These would have been able to travel the globe several times potentially. So I'm just trying to make sure I'm conveying the force of these tsunamis. And the tsunamis today, they even will lay down sediment the same way that the flood tsunamis did. You can see on the top right, the bottom of that, those are tsunami layers there. So a tsunami hit this area and laid down debris in a laminated pattern, in a horizontal parallel pattern. You can see there the gray kind of muddy area, it's been undisturbed. The soil on top of it has been disturbed, but the grayish layer there hasn't, and you can still see how the tsunami laid down the sediment. And there would have been quite a bit of these tsunamis laying down the sediment. They've been quite large, so while that is just a few inches in thickness, the tsunamis of the flood would have laid them down in feet, if not hundreds of feet at a time. And that's exactly what we see. And there could have been even larger ones. This model, you can see here in the bottom right how some of the tsunamis were even merging. Waves, just like when you have two ends of a jump rope, or a long rope, it has to be longer than the jump rope, I guess. You each make a wave at each end. Sometimes the wave can appear bigger, sometimes it's canceled out all on how it hits. And so the tsunamis would have been doing that as well. You can see how the red is kind of merging there at the sides. And if I remember correctly, this would be day 40 on the model there, so just as Noah was starting to be uptaken by the water. And all this would have formed what we call the lithostratigraphic column. These are columns of sediment taken from all over the world. Basically, they just drill down and they see all these layers in this kind of tube, or as you get to like the Grand Canyon, you can see it all just there on the side of the Grand Canyon. And we've known about this for about 200 years, well before long-age evolutionary theories became the mainstream. These are thousands of feet thick, and they appear to be thinnest in the center of the continents. Um, Basically, you're going to get an average about a half mile around the world, and they are consisting of a variety of shale, which is lithified mud, carbonate, which is like limestone, and sandstone. So all these are water-borne sediments. Now you will find some volcanic sediments in there as well, which makes sense with all the volcanism. All these are water-formed. Beneath these layers, we have what are called the Precambrian layers. These are the lower rocks. These are the rocks that have very few fossils. And for a time we thought there was no fossils in them, but we actually can find some bacterial fossils. And in a few places we can even find some algae fossils, which seem to indicate that this was a pre-flood beach where we found some of these. There's very few of them, they're very small, but we have found some areas of land that seem to have somewhat made it through the flood. And then we have the water sediments. These are the sediments laid down by the flood. And there's animal fossils in these sediments, and they're very, very large. We don't find these kind of sediments laid down today. And by that I mean we don't find them covering such large areas. We do find them laid down over the course of potentially miles, but not continental sizes. This requires a global event, something that take the entire globe by storm, basically. And then we have layers above those. These layers, just like the volcanic eruptions, get smaller and smaller. These are post-flood layers. These are showing us basically that the world post-flood didn't go back to normal right away. All the changes of the flood caused just subsequent catastrophes, much smaller, nowhere near global, but still very large. And we'll get into some of these as we get to that time. It's not the best picture, but you can see two kinds of yellow there. One, the darker yellow, is just the outline of the continent. The muted yellow is called the Sauk sandstone. I'm probably not pronouncing that right, but this is near the bottom of the flood layers. And it's just to show you how large it is. It goes from Maine, almost up to Newfoundland, down through Indiana, down to Mexico, and then up just east of Alaska, and then over to Greenland. It covers a wide range. Now, these sediments are tens to thousands of feet thick. Modern sediments are only a few inches, like the tsunami sediment I showed you before. And so these are just humongously thick and wide covering. And this is not an exception. This is the rule for a lot of these flood sediments. They are very large. And they're all laid down in this finely layered laminated pattern. You can see here on the top right some of those laminated patterns. They're all basically horizontal, and there's virtually no erosion between the two, between each horizontal line. And this is extremely rare for today, because modern soil is what we call bioturbonated, meaning some life form, and that's the modern definition of life form, basically broke down the soil. It's either plants, burrowers, earthworms, moles, what have you. They can dig quite deep, and when they do that, they mix the soil. They change the soil, and they make it better for plants and stuff like that. And so the secular community explained these finely layered laminations by hurricanes. Massive storms come in, kill everything off, and then new sediment layers form. But it doesn't match with what we see hurricanes doing today. You will find some hurricane papers from graduate students. They will spend a few years, like 4 or 5 years, studying a marine environment. That's quite a lot of time, and no one likes to put that much time, energy, and money into something and then stop it when a hurricane comes in and destroys everything. So what they do is they then change the focus of their paper to focus on the environment recovering from that. And basically every time within a year, there is no evidence there ever was a hurricane. The soil is bioturbonated because new life forms move in and they recolonize everything, and unless you had a side-by-side picture of the before and after, you wouldn't have expected anything to have occurred there recently. And so how do we get these laminated sediments? It either means that there were no burrowers or there was not enough time to burrow in between each layer being laid down. And we know that there was some movement because we see footprints in some of these layers. So we know that there were organisms there, but they didn't have time enough to burrow. And so this shows that not only were they killing off everything, because we have all these dead fossils in here, but they didn't have enough time to start digging between it, which means these layers were laid down in quick succession. We do see this in the Dead Sea, but it's because there's nothing living there. It's the Dead Sea. And so again, no bioturbinates. And based upon these layers, we can get a lot of information. We can see how large they are, how thick they are, and get a good idea of what laid them down. We can even see how they were laid down, as far as which direction the waters were moving, based upon marks, dunes, ripples, crossbeds, and that kind of thing. And we can figure out their speed by this as well. I believe Dr. R. Chadwick went through a number of graduate papers. And graduate students, since they don't have a lot of experience what is necessary and what is not necessary, they put everything in their papers. And they just basically throw everything at the wall and see what sticks. And so even though from an evolutionary perspective, this information is not necessary, it's not useful, it's not what they want. But this Dr. Chadwick was able to go through and get a lot of this information that they just put in there. And he can actually see that, in general, it seems to go from east to west, a lot of these movements of water. And we'll go through some of that just for curiosity's sake. I will note that the layers that we don't have any information about, or the area on these layers we don't have any information, does not mean it wasn't placed down. All this means is that it was destroyed or wasn't placed down or somehow was removed. So we can't say it wasn't there, we can just say it's not there now. So we can only say for sure when we actually have an answer, not a non-answer. I hope that explains that. So the lighter color, we can't assume that there wasn't really anything there. But you can see the arrows pointing how the waters seem to be moving. And this has been corrected for the changing of the continents, because he does record that the continents were moving, and so he tries to calibrate for that. So there is a few assumptions in this. So this is the Cambrian. This is the lowest layer of the flood, the first layers. And then you have some others. And you can see here how the pattern is kind of blotchy in some places. Remember, we can't say there wasn't anything there. We just know there's nothing there now. The Denovian, and as we go higher, we're getting closer to the end of the flood. And these are the layers that we're finding dinosaurs in now, and then the last layer. And that's just for curiosity's sake, just a little bit of information there in case you want to have all the information in front of you with these nice little pictures. And that brings us to what are called megasequences. These layers are not just laid down at random. There is a pattern to them. A megasequence is basically a sequence of rocks laid down in a pattern of an erosion surface, very large particles, smaller, and then smallest, and then another erosion surface on top. This is because when a large area of water comes in, it's going to have enough force to erode the surface below it. And then as it starts to lose its force, the heavier, the denser stuff is going to start to drop out. And then as it loses more force, the next least heaviest, least dense falls out until you have everything falling out, but still the water's coming in, just can't carry this. It's not strong enough to carry it, so it erodes the top as well. All this is basically laid down in one event. And we see 5, 6-ish of these in these sedimentary layers. You can see there on the right that there's about 6. The Tejas, though, there is some discussion about because it isn't exactly like the rest. So it is a mishmash of a few different things forming that. So you can call that a runoff megasequence. So it doesn't really fit the pattern of the other 5. And all these are named after Indian tribes. The first 3, the Sauk, Tippecanoe, and Kaskaskia, I never can pronounce that one right, all those contain mainly marine fossils. That basically means that this was before the flood came upon land, which means very likely all these occurred within the first 40 days of the flood. And so Noah wasn't even in the water at this time, it seems. The Absaroka, the 4th megasequence, we start getting some land in there. And the Zuni is the one which we have a lot of the dinosaur fossils. And this would have been, or likely would have been, the high point. Again, we cannot be sure, or we have an absence of information. We can only be sure of what the information we have, because there could have been destruction of the floodwaters afterwards, and there is a lot of evidence for that. And this explains why 75% of the Earth is covered with about an average of 1 mile of sediment deposits. And again, I said they were named after Indian tribes, and they were discovered by an oil company employee in North America. They tend to be thin, or thick on the coast and thin in the middle of the continent. And as I said before, the Tejas, there is some disagreement because it's not a classic megasequence. It doesn't fit that pattern exactly. But it seems to be a remnant of eroded layers as well as some post-flood layering. So there's a total of 5 large surges that came of water over North America. Now, evolutionary geologists think this occurred over millions and billions of years versus weeks or months from a creation geologist. And I've already went through how some of these seem to be placed by the tsunami layers, and it does match very closely. You can see again, the tsunami layers, the unedited photo on top, and then you can see the lines being boldened on the bottom. This is exactly what we're seeing all laid down by tsunamis, just on a much larger scale in the lithostratigraphic column. And these seem to be collecting environments or biomes. So the first ones are mainly marine organisms because they were mainly in the shallow seas. Just like today, there were shallow seas like the Gulf Coast and stuff like that. And as the floodwaters rose, they came and destroyed these areas. And in doing so, they took more or less a snapshot of these areas, because when they came in, they killed everything and then they deposited them. Now, there is going to be some mixing, some that aren't deposited with others because of different densities, different amounts and stuff like that. Others are going to be brought in from other areas. So we can't be 100% sure that these are perfect snapshots, but they can give us a good gist of not only what animals were there, but what animals lived together. So if this were to happen today, we wouldn't expect to see giraffes, pandas, or kangaroos all in the same sedimentary layers. Thankfully, we know it won't happen today because of God's promise. And first, we're going to talk about the base here. This is called the Great Unconformity. You can see this at the Grand Canyon there. But this is basically a separation of the pre-flood with the flood layers. There are a few highs and lows. It's not perfectly flat, but the high layers tend to be very, very hard. So it means that they were hard enough that the flood didn't destroy them. But the vast majority of land was destroyed during the flood. You can see here the column on the left, the mega sequences on the right, and then an overlap of the timeline of the flood on the left-hand side. Hope you can see, I'm not blocking it with my image. And this on the right is a decent idea of what the Sauk mega sequence captured. So this is the likely ecosystems that were present in the shallow seas. As all this would have started about day 1. And this is the area that it's covering. Again, the area that is whited out, we don't know for sure there wasn't anything there, that didn't get placed there. It could have been destroyed after the fact as well. We just know it's not there now. And so you will see some holes, perhaps those holes were filled in. You will see some separated out. Could be that those were connected, very likely that those were connected, and then those were separated out later after the fact. Like in North America by the Hudson Bay, you will see a few little blue dots there separated by everything else. It's very likely that those were connected so that they all could have been laid down together. Next, we have the Tippecanoe. You can see there the ecosystem, and again, this is likely before day 40, since there's no land fossils caught in these layers. This just shows how quickly the first portion of the flood came up. It came up very quickly. And these are the layers that we see the Tippecanoe in, or the areas that we see the Tippecanoe layers in. Very similar areas. Again, shallow marine organisms, shallow marine environments, and then getting closer to land. The last marine is the Kaskaskia. I think I said it better that time. And you can again see some of the organisms we find in that. And this is the area right before that it would have hit the land, so right before day 40. And these are the areas that it seems to have laid down. larger areas. The flood is getting more worldwide at this time.
So, John, on the wide areas, is it possible we just don't have data? We haven't dug in those areas?
Some of that would be the case, but it's very likely that as another mega sequence comes in, it's going to destroy not only new stuff that hasn't been touched yet, but it can very likely destroy stuff that came before it as well. And so we don't know how much of this is erasure by a subsequent mega sequence.
I've got a couple questions on that.
Sure, go ahead.
So there's one here that says, are each of the layers happening over weeks?
Potentially. So we don't know how these were laid down as far as the exact time. We just know that sometime between day 1 and day 40, most likely based upon the fossils we find in here, that these layers were put down, since we know for sure that Noah wasn't taken up by day 40. Now it could be Noah was at the highest point and all these other layers occurred within the first 40 days. We're making some assumptions with that. If that's the case, this would happen very, very quickly. But we're assuming that Noah wasn't at the highest point and was perhaps closer to shore, or at the very least, not extremely high. And then we assume that that 40 days would have had these three. Now, it could be that for some reason these three didn't collect any terrestrial fossils and just destroyed some of the terrestrial land and didn't really lay much down there. And that's very likely too. So we are making some assumptions with this. We can get close, but we cannot get exact information as far as what happened during the flood, but we can get relatively close.
One other question.
Sure.
It says, how have we found that these sediment layers cover the whole continent?
And so basically what they've done is they've drilled a hole, again pretty deep, and taken out the dirt in layering. So you can see, okay, we have this layer here, and then we can test it with the hole we've dug way over there. And they do this for mapping for oil. That's why they originally were found, is because this guy was going out, digging, testing the sediments, and he said, wait a minute, this and this match. And so we can see that. And then we have places like the Grand Canyon. All this vertical tectonics, all this moving of the land up and down, and erosion with these canyons, we can see that these layers are actually lined up and actually see it ourselves without digging at all. And that's why we can see the Sauk sandstone way down the Grand Canyon, but we can also see it in other layers because we can chemically test it, and it's the same thing. Now, these layers are not everywhere. So the mega sequences seem to be in that same pattern everywhere, but the individual layers within the mega sequence, like the Sauk sandstone, it isn't everywhere. But we can make sure that they are in the same order everywhere. We may not have sediment layer A through G everywhere, but we may have A, B, C, D, skip E, F, and G. And then another area we have A, B, C, skip D, E, F, G. And so we can then do like a Sudoku puzzle and cross-reference and match them that way. And so there is a lot of data, a lot of capturing of information just by going and digging. I hope that answers your question.
Is there like a number of locations that we've done that? 20, 100, 1,000?
I don't know, but it's quite a number. I'd assume more towards the thousands.
Because the oil company would have been trying to map a
Yeah.
large area.
And this is just one oil company. This is a number of oil companies, a number of private sector businesses, a number of public researchers, colleges, stuff like that. There's a lot of information, and then they publish this because that's what you do as far as the scientific community, to get your own credit. Any other questions?
That's it.
Okay. And there is some questions as far as the Kaskaskia megasequence, because this is the one where we start to see some terrestrial fossils. Now, the question is, are these truly terrestrial fossils? Because these are mainly plants. And this brings about the idea of that floating forest I mentioned before, because a lot of these tree fossils are hollow. They have hollow roots. And this is also where we start to look for coal. So it is some uncertainty whether this is truly land being affected or the floating forest that would have been just outside land starting to be affected. We don't know. And so that's the reason why there's some potentially land fossils in here, or potentially not land fossils, just on how you look at it. But the Absaroka is where we actually start to see a lot of the land fossils, and get to see a lot of the plant and the sheer amount of plants that were present before the flood. This is because this is where we start to see coal and other fossil fuels. You can see here a deposited layer, and I believe this is the Pennsylvania lycopod forest. So the lycopod forest is those floating trees as well. And this is a mix of land and ocean. I want to make sure I mentioned this before, is that even though the bottom layers are mainly marine with a little bit of the terrestrial fossils in it, the top layers still are mainly marine with a little bit of terrestrial fossils. This is because the pushes of water still came from the ocean. They were still destroying ecosystems in the ocean as it came up. And so we are seeing this in every layer, those marine fossils. So just because we are capturing these environments doesn't mean they're not mixing. And that's one thing that I want to make sure is because you always see dinosaurs in a very wet environment with a lot of marine fossils with them. That's just because they've been found in the same areas. You can assume that they were in the same environment, but you can also assume that they were in completely separate environments. We just cannot be sure with that because the waters came from the ocean and brought with it a lot of death and capturing of those fossils, of those organisms. All right, where was I before I got sidetracked? All right. And we can see a dramatic uprise of the ocean at this layer, at these levels. This is likely about day 40 to day 90. We just have a rough estimate of the timeline. We have a few verses telling us a few details, and we're trying to match those details to what we see in the fossil record as well as the sedimentary layers. And this is also the time that the oldest ocean crust goes back to. We can have a pretty good idea of that because, again, of the cross layering, when you have some sediments on top of this and some sediments on top of that, and so you can get a good idea of a indirect timeline. We don't know exactly when it occurred, but we know this one occurred first and this one occurred second because of the layering. One being on top of the other means that the second one came first. First one, the lower one came first, and the higher one came second. There we go. And here are some of the ecosystems that are caught by the Absaroka. We start to see some of the land creatures, the lycopod forest, and still have a good collection of marine fossils, marine creatures. These would have likely been the lowlands of the pre-flood world. And again, likely this would have been when the rains finally stop. And these are the layers of the Absaroka. You can see that there is quite a bit more. And again, we don't know if it is truly more or just that it destroyed a lot of the previous layering sediments. And last, the Zuni. Now, this would have likely been the high point of the flood, but we don't know for sure. If we assume that, though, it would have been just before day 150, sometime in there, and reached its high point about then, as it covered all the mountains by 15 cubits. And this is also where we see a lot of the large dinosaur burials. There are some layers that are unaffected by this. They are called shield areas of the continents, meaning that these are the areas of the continent where the lowest rock layers are still present. That's what we're living on today with some minor sedimentary layer on top forming the dirt. Yet, there are again some holes in this. So it's likely that as the flood receded, it destroyed as nearly as much as when it came up. For example, the Hudson Bay in central Canada, there are some dots in there that aren't connected anywhere else. And so it's very likely that it came in from the sides and all laid down in connection. It wouldn't have skipped an area to place it in another area. But this could have been destroyed by the runoff and the glacier obstruction. There were glaciers post-flood. We will get into that and how they formed when we get to that chronologically. But this is the sheer size of destruction. This is an area in the western US that has just massive amounts of dinosaur fossils. I would love to go out there and spend a few days digging in a number of these places here. There's a number of burials that have millions of fossils in them. Most of them are fragmented. Not a lot survive. We find very few whole fossils or even partially complete fossils. It's just because of the cavitation of the waters and just the sheer destruction. So it's beautiful when we find one, but extremely rare. Again, we have these dinosaur fossils found with marine fossils, And what's very interesting as far as the Montana massive graveyard is there's 10,000 adult Maiasara. No juveniles though, which seems that there was some warning that there was something happening. Remember, it likely didn't hit land until day 40. The ark itself wasn't lifted up until day 40. Yet all the storms, earthquakes, and even tsunamis are likely hitting at this time. This is a massive warning that something is happening. So some of these animals probably fled whenever they saw the danger starting to hit. They didn't escape, obviously. The humans as well would have likely had some idea that something was happening. And just as we see all through history, they probably went to high mountaintops trying to appease either God or gods, however they believed at this time. But this wasn't something that came upon them suddenly. This would have been a very terrifying and frightful experience until it finally did hit them very quickly. But here are a number of the ecosystems captured by the Zuni sequences. A lot of variety in this one, again, both marine and land. And these are the layers that it covers. You can see there the dots in North America. I think I can zoom in on it. Perfect. Hope everyone's seeing that online. But you can see those two little dots there in Wisconsin, I believe, around the Great Lakes there. Those would likely have been connected. We don't know if the entire area would have been filled in and that was destroyed by glaciers, or if it would just would have been connected to the sediments to the west of that. And you can see in a number of other places similar feature like South America and so on. And last, the Tejas. The Tejas isn't a complete mega sequence. It doesn't have the layers with the most dense and the lowest layers and then less and less dense. It's kind of a mishmash. But some still call it a mega sequence. And there seems to be a reversal in the flow direction. So it's very likely that this is the runoff of the flood, or at least in portion is that. You can see how some of it was collected in the Gulf of Mexico, which as it receded, it would have collected a lot of those newly laid layers with everything in it and pulled it with it, which explains why we have a lot of fossil fuels in the Gulf of Mexico. Now, there could have been something between the Tejas and the previous megasequence. But there's so much destruction, we can't be 100%. We can be pretty sure of what was there, but we can't be 100% just because of the sheer destruction. There's a few missing places, a few missing pieces that, unfortunately, unless we can get in the Tejas sequence with, in the Gulf Coast and goes diving for it, it's very unlikely that we'll get those answers. And even then, that's assuming that going through two mega sequences, this material wasn't just completely obliterated. And it's likely here that we'll find most of the human fossils if we can find them at all. Now, that's assuming that this hit after day 150, that they survived close to day 150 and were killed with the remnants of the Zuni, but were taken off by the Tejas. And so there are some questions about that. We don't know for sure. We do have human fossils that we have found, and we will go through those at a later date. But whenever they find one, a secular scientist will always say, oh, there's a rock slide, it got moved down somehow, and yet there's very little evidence, if any, for that. And it also makes sense with our understanding of the plate tectonics, because at this time, we have 80% of the mountains are rising. We know this because of how the sediments are layered. We have layering from previous layers on these mountains, but we don't have layering of subsequent layers on these mountains, meaning that they were raised up. So as the waters were receding, it seems the mountains came up at the same time. And you can see here the layering of the laying down of the Tejas sequence. And this is likely when Noah and his family landed in the mountains of Ararat. You can see a few white spots there. That's where the mountains of Ararat are, just west of that red dot. And so it's not very big, but it doesn't need to be big. And by not big, I mean comparatively speaking to some of these continental shield areas. It would have been plenty to catch the ark. And even then, they stayed in there for quite some time. And I will upload this afterwards so you can go through and with a closer eye for detail. And I also want to make note that the continents would not have been in this location. This has been what we have today. I could not find a graphic that had these layers with how they were in the movement of the continents. Now the Tejas sequence would likely have been pretty close to this, but the other layers likely wouldn't have been. And so I could not find one that was altered to show how the continents were at that time. I apologize for that. If you have a degree in graphics design and you want to start merging some of these together, feel free, let me know. I would love to have that afterwards. So you can see here how all the continents seem to have a very similar pattern. You have some like Europe that have more of the fourth mega sequence, but in general they fit a similar pattern with very little of the first and more of the last. This could be because the flood came relatively slow layering at first, or it could be that the subsequent layers destroyed a lot, and maybe Europe didn't have the subsequent layers destroying as much of the fourth mega sequence. Again, some questions we don't know. But just to end this, we'll go through and I'll show you them side by side, or in sequential order. So here is the first Sock, then the Tippecanoe, Kaskaskia, likely day 40 happening here, the first land about to be hit, the Absaroka, the Zuni, and I apologize for the change in the tint there, and then the last, the Tejas, everything running off. And so I just want you to show you how large this was and how destructive these water layers were, this upcoming of water. It was truly a horrible time, and they would have known it was coming once it started. The earthquakes, the volcanism, the sheer storms and rain, the floodwaters coming on, it would have been a very terrifying experience for both man and animal. And this was a terrible judgment. Thankfully, Noah and his family were somewhere floating in these waters. The waters would have been the safest part, but even that wouldn't really have been safe. There was a lot of destruction even there. Thankfully, God was with him. God watched him. God made sure he was safe. He brought him through this judgment. And there is a reason why the New Testament compares this judgment to Christ's coming judgment. It's going to be a horrible judgment for those that are found guilty. Thankfully, we have that promise of being pulled through this. Thankfully, we don't have to look forward to such a devastating judgment. Are there any more questions that have come in? Any more questions here? Okay. Well, that's it for today. We will go over a little bit of this next time and finish up the waters. And we may start to go into the fossils that we find here and some of the information that they tell us. Looking forward to going with that with you then. Thank you.